In this video, we are going to calculate one more problem based on the photoelectric effect. The question is, what is the energy of photon in joules associated with a photon of wavelength 4000 angstrom? And also here we need to find the energy of photon in electron volts. You must remind everything that is about in modern physics we need to calculate everything in electron volts only. That is the main key point here. So what is the question? Energy of photon in joules we need to calculate, and the photon of wavelength they already given, that is 4000 angstrom. Also here we need to find energy of photon in electron volts. For a single photon here we are calculating the energy of photon. The wavelength is 4000 angstrom and the energy of photon in joules and electron volts we need to calculate. That is the question about. Okay, so here we already know that whenever they given energy of photon and wavelength in angstrom, we need to find the problem based on this formula. That is, energy of photon is 12400 by wavelength in angstrom electron volts. This is the formula we already learned. So the next formula is energy of photon. We need to find here is in joules. For that we need to use this formula. That is, energy of photon is equals to 2 into 10 power minus 25 by lambda in meters whenever we are calculating this in joules. This is the formula we need to remember. So first we need to substitute this value. First we are going to calculate the energy of photon in electron volts. Substitute these values in this formula. Energy of photon is 12400 by, what is the wavelength in angstrom? They are already given 4000 angstrom in electron volts. So the solution is 3.1 electron volts in. This is the energy of a single photon. Whenever they given 4000 angstroms, the energy of photon is 3.1 electron volts. So the next one is here, the question is we need to find the energy of photon in joules as well. So energy of photon is, the formula is very important formula. This is in the further sections we need to calculate so many problems based on this formula. So energy of photon is 2 into 10 power minus 25 divided by, here lambda is in meters joules per second. Okay, actually they are given the wavelength is in angstrom, but the wavelength, the formula here it is in meters. How we can calculate? Actually they are given in angstrom, but the formula is in meters. So we need to convert angstroms into meters. What is the conversion? What is the conversion? In the previous classes we know about the conversions also. The meters to angstrom conversion is 10 power minus 10. Directly we can write it as 10 power minus 10. Whenever we want to convert from meters to angstrom, that is 10 power minus 10. So now substitute these values into this equation. Energy of photon is 2 into 10 power minus 25 divided by, what is the wavelength? 4000. 4000 into, what is the meters to angstrom? 10 power minus 10 joules. Here we are calculating in joules. So the energy of photon is, after the calculating we are getting the solution is 0.5 into 10 power minus 8 joules. This is the final solution. Whenever we want to calculate in energy of photon in electron volts, this is the formula. And whenever you want to calculate energy of photon in joules, and this is the formula. These two formulas are very, very important in the further sessions. Okay.